blue, my shirt's like blue, so I'm going to go with that, Elijah. All right, so let's go ahead and get started so I can get you guys on your way today. I see Mackenzie, Caitlin, James, Daniel, Greta, and Elijah. You guys are all here. Elijah, you actually inspired me to a little bit before I got on, which was why I was a minute late. We were talking about ellipses on Monday, and you said, oh, an ellipse is kind of like two parabolas that intersect with each other. No, it's not normal. I was just playing around. So I was like, well, what if I made two parabolas? So I have the blue and the red parabola, right? And what if I made an ellipse that kind of fit in the circle? So I just thought it was kind of interesting to compare the graphs of two intersecting parabolas and ellipse. They don't actually follow the same path because their equations are different, but they kind of look the same, right? And both ellipses and parabolas do have a focus point, which, or foci, or whatever you want to call it, right? Which is, you know, somewhere around here to make your Teenage Mutant Ninja Turtle. You know there's a parabola that follows the ellipse shape. I'm sure there is a parabola that follows that ellipse shape, but you're always going to kind of have this intersection here. I'm sure there is out there. I agree with you. Okay, so that was just my fun 30 seconds this morning. You know, fun with math. All right, so let's go ahead and get back to ellipses. We had so much fun on Monday making our own ellipses, right, with the tags that everybody loved that activity, right? So let's just do a quick review of what an ellipse is, and let's do some equations with it. So an ellipse is basically the shape like this. I think you guys said it was like a squish circle, oval, I don't know what you want to call it, Teenage Mutant Ninja Turtle, all that fun stuff, right? The definition of an ellipse is that if you have fancy oval, that works. If you have these two focus points, any point on the ellipse is going to be equal distance when you add the distance from one focus point to that point P plus the other distance. Okay, so I don't feel like I explained that very well, but if I pick this point, so they have point P, if I pick point A over here, and I drew my distance from point A to the first focus point and to the second focus point, this total distance of the black line, so from the focus point to the ellipse to the next focus point, that total distance is a constant. Okay, so if I pick this point down here at the bottom and I draw my line from the focus point to the ellipse back to the focus point, this distance is going to be the same. So that was kind of the point of why we did our little hands-on experiment, that the definition of an ellipse is that every point is a constant distance from the two focus points. Okay. So just some features we will review again, right? We have two ellipses here. There is a horizontal ellipse and a vertical ellipse. Okay, horizontal is obviously wider across the horizontal axis, while vertical is, you know, longer across the vertical axis. So that works out nicely for us. And we call the vertex of an ellipse, let me switch colors. Let me read Elijah's question here for a second. So we've got the vertex of these, the two, basically the largest part of the ellipse, right, on the major axis. And we actually, over here, you'll see that the vertex are also on the major axis. Okay, I have a quick question. What is the equation for a vertex and focus location question, as in making a oval, only the vertex and focus locations. Oh, okay. So is that an actual question from your book, or how would you actually do that? Okay, so that's where, if you have, well, I didn't know if there was like a question from the book. Give me like 3 minutes, Elijah, and then we'll do that. I promise. Okay, so you have your vertex or your major points on your major axis, right? And your co-vertex is what's on your minor axis. So we label the vertex by A. So you see here, the vertex is your A point. And A depends on if it's a horizontal ellipse, then A is in the X position, right? If it's a vertical ellipse, then A is in the Y position. So A is kind of like the, I don't know, the alpha male of the ellipse, right? It kind of controls whether or not you have your horizontal or your vertical axis. It always matches up to the bigger number. And B is like the second, it's second in line in the alphabet. So it gets the smaller side. And that follows through with the equation. So you see an equation for an ellipse with a horizontal ellipse, right? We have x squared over a squared plus y squared over b squared equals 1. So a is kind of the controlling that this ellipse is horizontal, and that's your bigger number. Now, when you want your ellipse to be vertical, then a is kind of controlling the y aspect of your ellipse, right? Because y, that's the vertical axis is the y-axis. All right, so the equations look very similar. You can see, obviously, you can see them here on your paper. They look very similar, but you'll notice that the A and the B are flipped when you talk about horizontal or vertical axis. And that's just because whatever is kind of the controlling, the larger vertex, that's kind of controlling what kind of ellipse that you're going to have. And then the last equation, so they kind of show you here, they say if it's the horizontal, then A is going to be bigger and your vertex is going to be at A, right? But if it's a vertical, your A goes under your Y because that's vertical corresponds to the Y axis and goes here. And then the last little thing that's kind of like written in a bunch of words, but it's actually really important, is where are your focus points? So your focus points are always at C squared equals A squared minus B squared. So that's always the equation, and that works out. It always works out because as long as you keep your A under whatever the major axis is, then that's going to work out. It's fun, right? I hear cheering through the computer so loud. Okay, so Elijah, so what if they give you, so I like the enthusiasm. So you're telling me that they have a vertex at 3, 0 and a co-vertex at 0, 3? Okay, so what you're going to say, that's actually an ellipse that's going to be a circle. Okay, because you have the same coordinates. So it's actually going to end up being a circle. But like say you have well, is this one of our homework problems? Let's see. Let's scroll down a little here. Ah, like this. Okay, we can do number 33. Sure, let's do that. Sorry for the loud microphone. Try to move my mic away. Okay. So Elijah, sorry, I know. I was like pulling my microphone away and coughing at the same time. It probably did not sound very good. I should have just hit my mute button. I am completely fine doing 33. Can we do a little bit easier one first and then get to 33? No, I know, mute button, all or nothing. Let's start a little easier. Let's get our brains warmed up so that by the time we get to 33, we're not like, what? I don't want to start with the hardest. Your brains are all warmed up. All right. So let's just, your coffees, I think. I hope so. So let's do these two first. We have graph the equation, identify the vertices, co-vertices, and foci of the ellipse. Just know you had to say that, right? Okay, so what do you want to do? Actually, before you even graph it, you should be able to tell if this is a horizontal or a vertical ellipse. And really, you should be able to graph it without even using your graphing calculator. I'm not saying that you have to do that, but that you want to. Oh, we did number one in class, didn't we? We did number one in class, right? I remember now because I was looking at my notes and I had the wrong thing. So we'll start with number two. So we have 25x squared plus 9y squared equals 225. So, you know, math books try to trick you and all. And you're like, this doesn't kind of look like the equation of a standard ellipse. What's going on here? So guess what you get to do? We get to just manipulate the equation a little bit to make it look like the standard equation for an ellipse. So this is what the standard equation of an ellipse looks like, right? It's x squared over a number plus y squared over a number equals 1. Well, how are we going to force this to equal 1? Okay, so I've had a lot of students before when they see this equation and they want 225 to equal 1. Yeah, they just say, oh, well, then I'm going to subtract 224. And that'll leave 1 over there, which is true. That doesn't quite get us to what we want to do. Okay, so what you want to do in order to get a 1 over here is divide by 225. Okay, so what's 225 divided by 225? It's just 1, right? I'm going up here. So then we have 25x squared over 225 plus, I don't know why, 9 squared, 225. So now you get to, yes, bust out your fraction skills, right? How can we simplify 25 over 225? By crying? Maybe. You just say, how many times does 25 go into 225? Thankfully, it goes in easily, and it's just 9. 1/9. Yeah, not too bad if they go into each other, right? Oh, and then if you divide 9 into 225, you get 25y squared. And Elijah, I love it. Elijah said, okay, this is vertical. How did you know that that's vertical? Because it's easy. You know it's vertical because 25 is bigger than 9 and 25 is under y, right? And when something is bigger on the y-axis, that makes it vertical. Yeah, nice. Got it. Elijah and Greta have it. Hopefully everyone else is like, yeah, got it. Okay, so since my 25 is bigger, then that's how I know that this is going to be vertical without even graphing it. Okay, now without even going into Desmos, I should actually be able to graph this really, really easily, right? I'm going to attempt. That's no. I really should be doing this in Paint. I do much better in Paint than this whiteboarding thing. Here we go, Paint. Help me out. I don't know, Elijah. Am I telling you you're right? Trying to draw a line is all I'm trying to do, people. All right. There we go. Okay, so we've got 1, 2, 3, 4, 5. 1, 2, 3. Okay. Yeah, just use Desmos, Elijah says. Why are you making it so hard? Because I want to prove that you could do it, right? All right, so if you look back at your equation page, back over here, and we said that this is a vertical, we already decided this is a vertical ellipse, right? So that means that whatever is under my y squared, that's a, and then whatever is under my x squared, that's b. And a is my vertices, and b is my covertices. So when I draw this, yes, I know that my vertices are going to be at 0, 5. Now, how do I know that they're going to be at 5? Because you look at 25, and 25 is 5 squared. Yeah, or because of the homework, right? And 9 is 3 squared. So if you look at the equation, it's x squared over b squared plus y squared over a squared equals 1. So that means that my a is 5, so it's going to be at 0, 5, and my b is 3. It's right here. So if I go to graph this, my egg, it's in time for Easter, should look something like that, right? I know, I do too, Greta. Greta said she liked that 9 and 12 or 25 were perfect squares. That makes life easier. Okay, so the last part is, where are my focus points? This one is the least obvious, right? So the focus points are always, thank you for that. The focus point is always at c squared equals a squared minus b squared. Okay, so a squared is 25, and b squared is 9. So 25 minus 9 is 16, right? C squared equals 16. Oh, another perfect square. That means C equals 4. So my focus points are at 0, 4. They're like right here and right down here. Oh, Elisha, plus or minus, you're right. So if I flip back to my notes, you'll see that your focus points, this is totally easy to see over my writing here. My focus points are at 0, C and 0, negative C. And you'll see if it was on a horizontal axis, it's going to be at C0 and negative C0. All right, so now we finally can use Desmos, right? And go way back to our original equation. Where was that at? 25x squared plus 9y squared equals 225. 25x squared 9y squared equals 225. Oh, I'm gonna do some zooming out, right? It's a much better egg. So you'll see that my vertex is at 0, 5. And negative, or in 0, negative 5. And my co-vertex is at 3 and negative 3. And we said that my focus is at 4. Now there's no, all right, can't get political on the chat or I have to turn it off, misters. Our focus points are at 4 and negative 4. So anybody have any questions about that? Number 3 through 13, you're going to do this. You're going to graph the equation, identify the vertices, covertices, and foci of the ellipse. Okay. All right, so then 17 through 33, they're going to give you some characteristics of the ellipse, and you are going to write the equation. Doesn't that sound fun? What's up with this today? It's easy. All right. Okay, well, if it's easy, we'll just do one of each so you can make sure that you're good. Okay, so we've got a, here. I'll be nice. Your notes will not be complete, but I'll be nice and we'll just do, I don't know what I've got going on here. We'll do one each from your homework. How's that? I got this. Yeah, you want to do some geometry instead? Okay, so we've got, let's do number 25 from your homework. No geometry. You haven't even done geometry yet, Greta. You might love it, right? You might like it. It's not too bad. Oh no, I picked a hard one. Not hard. But I guess we'll do 21 first. I'm trying to give you the easy one. I want to do an easy one and then, get a little harder. So let's do 21. Not that 25 is all that hard either. But okay, let's do 21. The vertex is at 0, 12. And the co-vertex is at, come on, pen. Co-vertex is at 11, 0. All right, so what kind of ellipse is this? Which number is bigger? 12 is bigger, right? Yes. And 12 is in the y position. So that means that our y component of our ellipse is going to be bigger and we're going to get a vertical ellipse. Okay, so the equation of a vertical ellipse is always x squared plus b squared plus y squared plus a squared equals 1. So what are my a and my b? So a is your major vertex. So if you were just to sketch this, right, it's going to actually look really close to a circle. This is going to be a really big ellipse. Okay, but your a is going to be at 12 and your b is going to be at 11. This is at 0, 12, and this is at 11, 0. So that means that that a component is 12 and b is 11. So then we just plug it in. So we've got x squared over 11 squared plus y squared over 12 squared equals 1. So if you do some simplifying, you get x squared over 121 plus y squared over 144 equals 1. So this would be our equation of our ellipse. Okay. How do we check if that's right? Desmos, right? You just type in the equation that we just solved for. Zoom out a lot. I think my representation was pretty close to this, right? So we should, in theory, have a vertex at, there we go, 0, 12, which we do, and a covertex at 11, 0, which we do. Now I was just looking, I don't even think it asks you to find the foci. Yeah, that's true. And Elijah, you should get the same answer for both those because you're just reframing the equation. Well, if we really wanted to have some fun and find where the foci, whatever you want to call them, those points are, what would it be? Just a good review. It would be c squared equals a squared minus b squared. Always that equation, okay? And we know, we've already done the work, right? See, it's 12 squared minus 11 squared equals c squared. So c is basically going to be the square root of 12 squared minus 11 squared. And I'm feeling a little lazy, so let's throw that in Desmos and see what we get. C is going to be the square root 12 squared minus 11 squared. So this is actually interesting. So the focus points for this particular equation are actually at 0, basically 5. So about right here. And about right here. Okay, let me read Elijah's comments. If you put x squared, where did you get those numbers from? You eyeballed it. All right. Apparently Elijah has a talent for eyeballing where the foci point is. Focus point. You probably do. You probably have a better artistic eye than I do and can see what it's curving about, but I can't see it. We just got our sideways Teenage Mutant Ninja Turtle. I believe you. See, I would say, Elijah, it's probably all, you have a much more artistic side. So anyone that has an artistic side, I know ellipses are a common art form that's used in a lot of, art things. So you probably have a better feel for what that means anyway, right? No, but you're artistic. Well, if you're Elijah and you can eyeball where the foci point are, then that's great too. Okay, so now finally I get to your question, Elijah, right? Oh, I thought that's what you were saying. Finally, we're going to get to 33. Oh, you can eyeball the whole oval. Okay. I, I'm much more on board with that. I thought you were saying that you could eyeball where those points were. All right. Let's actually do 31 because I keep feeling like we do keep doing vertical ellipses, and I feel like the horizontal ellipses are feeling a little left out. So let's do 31. That's right. I feel like this poor horizontal focus is at. Okay, so basically they're giving you 2 points. And there's several different combinations of this from 23 to 33. They give you different combinations of numbers. But if you have 2, oh, that's a bummer, Elijah. So homework, learn from Elijah that 17, 19, and 21, they give you the vertex and covertex. That's easy peasy. Plug in, you're done. Starting with 23, they give you the vertex and a focus. And then starting with 29, they give you the covertex and the focus. So just pay attention to what points that they're giving you. Okay. So what I said is let's do number 31 because I want to do a horizontal ellipse. How did I know that 31 was a horizontal ellipse and not a vertical ellipse? Well, I know because of the focus point that they gave me. So the focus point is always on the major axis, and this focus point is on the x-axis. So I know that this is going to be horizontal. Did I spell it right? Probably not. Horizontal. Nope, the definition is the focus point is on the major axis. Okay, so when I know that this is horizontal because the focus point is on the major axis and the major axis is x, that means that it's x squared and the a squared goes under the x squared because it's horizontal. Plus y squared over b squared equals 1, right? And the other equation I know that's always true is that c squared equals a squared minus b squared. Well, I just said couldn't calculate the focus point as well as the matrix. That's what you're missing on your parabola example. Oh, the one. I'm reading. Sorry. Apparently, I don't read all my words out loud, huh? Okay. Got it. I agree. All right, so these are my 2 equations for a horizontal ellipse, right? Now I've got to figure out what, I've got a bunch of numbers up here. Which one's A, which one's B, and which one's C, and what am I trying to solve for? Okay, well, the covertex is always like the second fiddle, right? So it doesn't get the A, it gets B. So that means my B is going to be equal to negative 5 over 7. Okay, but we can also make it positive. We don't have to, right? Exactly, Elijah. And my focus is not a vertex or a covertex, so my focus has to be 15. Now, you'll notice these both have negatives. It's because you have the negative and the positive. Really, I mean, once you put these into the equation, they're all going to get squared. You'll notice it's a squared, b squared, c squared. So it really doesn't matter if they're positive or negative because they're going to get squared. So Elijah's saying c squared is negative 15. Technically, I think technically how you would say this is that c is positive 15 and b is positive 5 over 7. It's just when you get to your, no, negative 15 is not the outcome of c squared. Negative 15 just represents c, the number c. Okay, we'll do it. All right, so let's fill in these two equations with what we know and figure out how we're going to solve for. Basically, we're looking to solve for a, right? Because once we have a and b, then we can write our equation. So what we have so far, let's start off with c squared equals a squared minus b squared, right? Let's rearrange this. Because we have b and c, let's rewrite this equation and make it c squared plus b squared equals a squared. Because really we want to solve for a or a squared, right? So c squared is 15 squared plus b squared, which is 5 square root of 7 squared, equals a squared. Okay, so 15 squared is, I don't know, my squared's that high. $225, I should know that. 225. All right, what about this? How do you do 5 square root of 7 squared? So this is really just 5 squared times 7. Right? Is that what you're saying, Elijah? Equals a squared. So I get, running out of room, 225 plus 175 equals a squared, which ends up being 400. So a squared equals 400. Oh, I think 400 is the perfect square. It is. So if a squared equals 400, that means a equals 20. All right, so I think there's a question about this right here, right? How did 5 square root of 7 squared become this? How to become 5 squared of 7? It's because you can distribute the square, right? So we can distribute the squared to 5, and then you can distribute so 7, the square root of 7 squared is just 7. So we have 5 squared times, and then basically 7 is alone because the square root of the square undoes each other. I don't know if I answered that. Anyways, okay. So we figured out what A was. A is 20. So now what is the point? The point is to write an equation. So let's write an equation in green. St. Patrick's Day, right? So x squared over a squared, which a squared is 20 squared, plus y squared over b squared, and b is 5 square root of 7 squared equals 1. So this is just filling in the blanks. I solved for A, I have B, I fill in the blanks, and I get my equation. Your book may also write it as x squared over 400, right, plus y squared over 175 equals 1. Those both mean the same thing. Yeah, same thing. So now in a final, plotting this out, we can go to Desmos and see how well we did, right? So we said this is x squared divided by 400 over y squared divided by 175. Much. I just retyped it. Okay, so our focus points are at negative 20 and 20. All right, our foci are at 15. And then our co-vertices were at 5 times the square root of 7. So I don't even know what the 5 times the square root of 7 is, so let's just do that really fast. 5 times the square root of 7 is 13.2. So our co-vertices are at basically 13.2. Okay. Sound good? Does anyone want to see another example? You guys ready to tackle ellipses? Yes, you got it? All right, I am going to show you what's coming in 9.5. We are not going to go over the whole section, so I'm not assigning it, but I just want to show you what it looks like because it's way easier to look at on here. I know. I promise I won't take the whole time. Okay, so let's make this even a little easier. Let's see. Make this a nice, easy ellipse, right? So we have x squared over 400 plus y squared over 100 equals 1. So that means that my co-vertices, or my vertices are at 20 and negative 20, and my co-vertices are at 10 and negative 10, right? What happens instead of hitting plus here if I subtract? We get something called hyperbolas. So, what? Yep. So when you're adding those two terms together, you get a nice, pretty little ellipse, right? It looks really nice. Hyperbola is Hyperbolas. Hyperbola. There you go. Hyperbola, right? It's not to be confused with whatever there's some English things, right? Hyperboles, and I don't know. Isn't it something like that? It's been a little bit of time since I've done that. Okay, so basically, what happens when you subtract is that instead of our ellipse kind of coming together and forming this nice little ellipse shape, right? Instead, we have these two opposite looking parabolas that kind of have this relationship to each other. Yep, this is what happens. And then, excuse me, the definition is that you're still going to have some focus points. Okay. Say they're I don't have the skills like Elijah to eyeball them. I'm just teasing Elijah. So say you have this point here and point here are focus points. I'm not saying that those are exact. Okay, so you still have the focus points at these two kind of parabola looking things. Okay, so the definition where in a parabola, the distance from the ellipse to the two focus points, when you add them together, it was a constant. Now, if I take a random point on here, okay, and I say, okay, I've got my focus point to my hyperbola to my other focus point. So if this is distance 1 and this is distance 2, when I subtract distance 2 minus distance 1, it's a constant. So constant. There's an S in there. Totally. Okay, so hyperbolas are kind of the opposite of ellipses, right? It's kind of the anti-ellipse. Ellipses are all like coming in together and the focus points are together and you add the two distances from the focus point to the ellipse and they are constant. Hyperbolas are like the opposite, right? You use subtraction, they're going apart from each other, and the distance from each focus point to the hyperbola, when you subtract those distances, is constant. So that's how I kind of like to think about it. There's more properties than that we'll talk about, but basically they're kind of the anti-ellipse. Right? So we really just have this section left on Monday. We're going to go over 9.5, and we'll take some time to do that because there's some different features that we want to talk about that. And then 9.6 is our last actual section in here, and that's where we're going to talk about, I think it's 9.6 is our last one. We're going to talk about shifting these graphs. I think our notes just go to 9.6, don't they? Maybe we should do 9.7 for fun. Oh no, we got 9.7 too. We got time. So we'll be doing this chapter for a little while longer. Nope, you didn't miss 9.6. 9.6, basically what we're going to do, Elijah, in 9.6, and you guys can, if you have extra free time, you can do this for fun. Let's just go back to our nice ellipse, our comfortable ellipse, right? Nice. Your favorite pastime. What if we want, so up to this point, your book has been really nice, right? We're in 9.4. And the circle, the parabola, the ellipse, even in the next section, they're all centered around 0, 0, the origin of the coordinate plane, right? What happens if we want our ellipse to actually be shifted over and to not have it centered at 0, 0? So what you're going to do is you're going to do some trickery with the x, right? So if I say x minus 5 squared, you can see that that didn't pick very good colors, but it actually shifted my ellipse over by positive 5. Okay. And so if I wanted, another ellipse, let's say I'm making some art with Desmos. I could play with shifting my ellipse across the x-axis. So if adding in to my x term, x minus 5 and x plus 5 shifts my ellipse on the x-axis, what do you think I would do if I want my ellipse to go up and down? I'd have to do something to this y term, right? So if I take this original equation, put it down here, and add in plus 5 squared. So now I shifted my ellipse down. This, I think there we go. Shift my ellipse up. That's basically what 9/6 is, figuring out how to move the ellipses around. You can make some cool art design for me. One of you artistic people can make Desmos art, right? By shifting your ellipses. There we go. It's like a 3D drawing of a tunnel. All right, so that's all the fun you progress. That's all the fun that we can pack into one day. I know you're sad that you have to go, but I think you're now all ellipse experts, right? So go make ellipse. All right, guys, thanks for coming. Have a good day. I will see you all on Monday. Bye, Greta. Bye, Mackenzie. See you on Monday.